Hi, welcome to the second part in the USB power supply design series, and this time I'm going to start out by talking about the case for this thing and the selection of the case and the form factor and stuff like that, because I think it's very important for a lot of projects. In fact, it's absolutely essential for a lot of products to start out with how it's going to look and feel and what case you're going to build into it, what the user interface is going to be like, and your physical requirements like that, because that can determine often your electrical requirements as well. You know, if it's a tiny case and you've got a power supply, well, you're going to be limited to how much heat dissipation, for example, you can put into it, or what type of connectors, how many output connectors, can you fit a whole bunch, what input connectors can you have, all that sort of thing. So my requirement for this USB power supply, when I first came up with the idea for it, I had just done the microcurrent, the first version of the microcurrent, and you've seen that before. And so this was about in 2009 or thereabouts, and I had used the Australian-made Jiffy box made in Western Australia here by Altronics, and I really like those cases. They're very cheap, and of course they're made in Australia. I wanted to keep local content as much as possible, so I wanted my little USB power supply for my own use. I thought it'd be quite nice, so I naturally just built it into the same case, because I was already getting the board made, so on the same panel I could get these prototype boards made as well. So it made sense. That's why it's red, that's why it fits into the same box. It was just a no-brainer. I just quickly lashed it together at the time, but as you can see, it's really not that suited for, I think it's one of its intended purposes that it needs to be really small so that you can, say, throw it in your very thin, the outer pocket on your notebook case, for example. And this doesn't really cut it. You've got the huge binding post protruding up here, you've got big displays protruding there, and the case itself is thick, and of course most of the room in there is actually taken up by, it's just, you know, it's just space in there, nothing at all, just the binding post protruding from the bottom. So that's a pretty inefficient design as far as space utilization. You know, three-dimensional utilization of the space is very poor. So I didn't really think about it much more when I designed the second one here. I just decided to go for the knobs instead of the buttons here, and smaller displays, and I decided to mount the binding post on the end of the case. So this was designed to sit in here. It's got all the circuitry on the back, and this is designed to sit in here like this. And I was going to I thought I'd just put the binding post protruding from the back there, because you really, a few people have asked in the comments for the previous one, oh, use spring terminals or 4mm banana, low profile 4mm banana jacks, but really for a power supply I think it's absolutely essential to have a 4mm binding post, and these are dirt cheap, available anywhere, industry standard stuff, so I'm going to base it on this. So this was an absolute must-have requirement in my USB power supply, and it's a matter of, well, how do I mount these things? By the way, I know somebody posted a link for smaller profile ones about that long or something like that, that you can get from Newark/Farnell's or something like that, but they're more expensive, a bit more obscure, I don't know. I'm going to design mine around these industry standard 4mm binding posts. So how do I mount this? Well, it makes sense because I want this to be as thin and as small as possible. I want it to mount into that notebook case, so it obviously makes sense to mount them on the end like this. And that's what I did for this second version of the micro supply here, but it still had the big knobs because I was obsessed with having knobs on this thing, and well, it's just, you know, they just protrude and you can't slide into a case nicely. Knobs are great, but I'm afraid the knobs have to go, because I think one of the main requirements is that it's thin, can easily slide into a notebook carry case or something else. It's really as tiny as possible, the size of a credit card or something like that. So as I said in the first video, I'm going to abandon the approach I've used with the previous two, just very quick prototypes, because I didn't put much thought into them. I just wanted them for my own use. And so really, I think I'm going to ditch, well, I've got no choice. I've got to ditch this entire case because I can't be, wasting all of that volume in there. I haven't got room for the knobs. Even the displays are quite thick. Look at those. They're, it's just not going to work out. So have to ditch the entire concept of that and get a smaller case. And let's take a look at them. Now the case I'm actually going to use is one I really like, and I actually keep in stock because I think they're very useful, and they're probably one of the most universal cases on the market because they're heavily copied. Now, I got these from Altronics. You can buy them from Altronics and Jaycar here in Australia, but overseas they come from Bud Industries, or they come from a whole bunch of different manufacturers. One Hung Low brands, they all make the same box. So much to the point where I don't even know who the originator of these cases actually is, what company first did them, but everyone seems to have copied them, and I really like them. And they're available in not only several physical sizes, but also within each range they're available in different heights as well. And this is like the big 100 by 190 millimeter one. Sorry, I don't know in inches for you Yanks. We've got the smaller 80 by 150. We've got the 60 by 120 millimeters, and we've got the tiny one that I'm going to use here, which is the 50 millimeters by 90 millimeters, and it comes in three different heights available. You can get it in 16 millimeters height, 24 millimeters, or the one I'm actually going to use is the 32 millimeter height one. And I'm going to mount the connectors on the end like this. But, I'm not done yet. I've got a trick up my sleeve that not only saves cost, but also halves the height profile. So before I go into that, I'll just show you inside these. They actually come with end panels, and this particular one is in two halves like this. It's got the four mounting posts inside for a PCB. They've got vertical PCB mounting guides like that if you want to mount the vertical board in there. And the end grooves on these actually support a 1.6 millimeter PCB. So you can put in a 1.6 millimeter standard PCB, and you can use it as the front and the rear panels if you want to get them silk screened and you don't want to use ABS plastic, or if you want to have them actually have circuitry, you might have LEDs mounted behind them or whatever. So they're really quite nice, and these are unfortunately in the smaller start model here, which I'm going to use, they're not metal threaded inserts here, but if you step up to the other cases you'll find that they actually do have the metal threaded inserts, and they are quite nice, and they're very similar inside. One word of warning, if you're going to use these, be careful. Some manufacturers actually have the mounting holes. It might have the mounting holes in different locations or something like that. So just be careful if you are going to try and get a case from a different manufacturer. And the big ones are exactly the same. They come with the mounting hardware. They even come with rubber feet, and they've come with the front and rear panels and the metal inserts. And the bigger one is just the same as that again. So what I'm going to use is this tiniest little one here, which is 50 by 90 millimeters. But as you see, as I said, it comes in three different heights, this thing, and this is the biggest one, the 32 millimeter. Not because I need the height, but I actually need half the height, and you'll see why. And I think this is a rather clever product design decision that will not only get me one of the thinnest profiles I possibly can for this product, but also halve the cost. Now, of course, one of the things with using one of these cases with the end panels is, where does your display go? Because a power supply's got to have a display, and it's got to have switches, right? Obviously, I can mount my two binding posts on the end here, so just picture those mounted on the end like that. I can put them the standard 19 millimeter spacing apart. That actually does fit in there, not a problem at all. Okay, so I can mount those in there. They go onto my PCB, which is mounted in there, and I can put some little wires going down to the board down in there. And I can, on this side, I've got my USB input connector for the power supply, and that's it. So somehow I've got to put my display and my user interface, my switches, and no, I'm not going to make this thing just PC controlled. I want this to be standalone so that it'll have not only a voltage, be able to display voltage and current, either a single display or dual, and it's got to have buttons so that you can use the thing independently of any software. If it's just software only, I think it just loses all the appeal of that ability to operate it from virtually any 5-volt USB power source. I don't want to have to boot up the machine and run some software and all that sort of stuff just to output a voltage. It's ridiculous. Anyway, so how do you get the display on this thing, I hear you ask? Well, you can cut out holes. You know, the traditional approach using something like this might be to machine out, you know, the displays and machine out the holes for the display and things like that. But really, that is additional cost, and you can't really avoid that if you want a top surface on this thing. But I got the idea of thinking, what if I just split this in half and check out these two halves? What do you see? Do you see any differences between these two halves? I don't. It's because there's not essentially any difference apart from a tiny difference in the diameter of those mounting holes there, because one is designed for the countersink screw to go through on that side, and the other's a slightly smaller diameter for it designed to be screwed in like that. But apart from that, they're identical. So I got the idea of thinking, why don't I just, instead of using the whole box, use half a box like that? And I've instantly halved my profile like that. I can still mount my connectors on. Stick with me, I'll show you how I'm going to do that. And so not only have I halved the height profile on there, but I've halved the cost. I can use both halves of this thing, because who cares if one's actually got the protruding holes on the bottom and one hasn't? I'm not that fussed. The thing's going to be used like this. So how do you get the front panel display? Well, you mount your PCB in there and you just get a clear Perspex cover to go over the top, and you have it, and then you can see the display through the clear Perspex cover. And it just so happens that those 4 mounting posts up there, there's a little height difference in there. I'm not sure if you can see it, but let's get in. There's, you know, a couple of millimeters in there where that, where any clear Perspex thing on the top, front cover, can just butt up against that in there and just go over the edge like this, and it'll fit in rather nicely. So imagine that with a nice clear thing on it. You'll be able to see the circuit board inside. You can mount your display on the PCB. You can have some standard tacked switches coming up through holes in the top, and Bob's your uncle. All right, so what do we got here? We've got 1/2 of a very cheap case. I can get this case for like $2.50 in reasonable quantity, even here in Australia, let alone overseas or something like that. But because I can use 2 halves of it, I've halved my cost to $1.25 for a nice little compact case. And it's no bigger than a credit card. And well, here's a credit card. This is actually the swipe card to get into my office here, and it's, you know, it is no bigger than that. In fact, it's slightly less height than a credit card and just a fraction wider like that. Of course, it's going to be a bit more when you include the binding posts on the end, but let's not fuss over that. And it's going to be very thin like that. We're only talking, you know, the Perspex cover, we'll take the top bit like that. We're only talking 16 millimeters, 17 millimeters tops, because it does have a curved bottom on it like that. So it does rock a bit on the bottom like that, but hey, that's a feature, right? And we've, you know, look at the difference now in thickness between these two. There's a huge difference, and we're going to do away with the knobs and just have the buttons, those tactile buttons, protruding from the top here, just like these, but these little tactile buttons, but with an extended shaft on them so that they're the right height, because you can buy these switches in with different height shafts. It's just a different order code on the end of the part number. So there you go. It's nice, simple and compact. I really like it. And I know what some of you are thinking, am I going to have room to mount these binding posts on the end? Well, if you look at it, you have to, these things you don't actually punch a round hole for these. You punch a sort of a flattened hole, and there's plenty of room in there, as you can see, to plenty of height, top and bottom, to get a reasonable front panel, a reasonable amount of material, top and bottom, for those two holes. So that should fit in there nicely, and that will be, actually, where that ruler is, will be the height, will be the exact height of my Perspex panel. It'll sit in there like that, so I should be, and because it'll wedge up there, the panel itself, the front panel, will actually be, it'll sit in that groove in there and be wedged between the top. So I slide the panel in on both ends if I want, and especially on this end, slide it in, and then it'll be held in place by the 4 screws that hold on the top of the Perspex plate. Not a problem, should work a treat. And then of course, once you've chosen tentatively chosen a case like this, you've got to make sure that all your major size components are going to fit, and your amount of circuitry as well. So the biggest component on this thing is going to be the little 2-watt DC to DC isolation converter in here, which allows me to get my isolated power supply, because yes, I want this thing to be isolated so you can make it into a split supply and other stuff. As I've mentioned, I think that's an absolute essential. But its height is actually too high. It's not actually going to fit in there, because you remember there's got to be a PCB mounted on top of there. It'll be a standard 1.6 millimeter. If we needed to shave off some extra height there, we could go for a 0.8 millimeter PCB, but that will cost a bit more and be a bit less rigid than the 1.6. So that's, it's just too high there when you include a PCB on there. But we can certainly lay that down flat, and there's more than enough height in there. And if you actually measure it, there's enough height for a 1.6 millimeter PCB plus this thing to mount flat. Not a problem at all. And based on experience, based on my previous designs here, I know how much, roughly how much circuitry I'm going to have in this thing. I've got an idea for my display, which you'll see in a future video. I've got a novel idea for the display solution. No, I won't be using the same 7-segment displays I've used here. So I've got to fit, the display in here. I've got to fit the switches. I've got to fit the circuitry, and ideally, I want it all mounted on the top side of the PCB in there, because if I go for a dual-sided load on my board, I can mount components on the bottom. You can see there's a little bit of height in there on the underside of the board. I could certainly mount a whole bunch of surface mount components on the bottom, and if you really needed the space, you could do that. But a 2-sided load board is going to cost more than a single-sided load board. So ideally, I want all my components mounted on the top, and my board, of course, will be, it could be square like that, but I need it to be routed out here and poke out, well, not poke out, but come to the edge here. So then I've got my USB connector, which just pokes out the side here, and you can plug in the USB. But this board here, unless I need the space, doesn't really have to come around like this and go all the way out here. So I'm probably going to make it flat on this side, just behind these pillars, go around, have a little routed cutout, go out to the edge, so I've got my USB connector, and that will be the size of my board, and my display will show through the clear Perspex top, which might be, a millimeter thick or 2 millimeters or something like that at most, because it doesn't have to be strong. It just has to be, mount on the top and easily be laser cut. And I don't know how much that would cost, but I know it's going to be pretty darn cheap, because it's going to be fairly simple, and it's not a real big thick 10 millimeter thing or something like that. Should be very cheap. And so that's my case solution for this USB power supply. And I think it was quite a bit of a novel idea to use these two halves and then, halve the cost of my display. Sure, half of the ones will have these holes in the bottom, the other half won't. I may have to even supply possibly slightly different screws, slightly different diameter screws to go into each one, but even if I have to do that, it's not really a huge hassle. I probably won't have to. They'll be slightly looser fit on these ones and slightly tighter to screw in on these ones up here, but not a big deal. And of course, one of the problems with choosing a housing for something like this is there's no shortage of little small ABS Jiffy boxes like this on the market. They're a dime a dozen. You go to DigiKey or you go to any of the major enclosure supplier websites. There's a whole list of them on the EEVblog wiki. By the way, if you go to eevblog.com/wiki, there's a list of enclosure manufacturers on there, and there's a dozen of them, and they all make a dozen different little cases, so it can often be hard to choose which ones to pick. But I like these because I've used them before. It just so happens to fit my height requirements. It's just big enough. I can split it in half to halve the cost, and there's quite a few little things which are added up, which I think made this probably an ideal solution for like this. I did look at a few others on the market, and they just seem to have some sort of showstopper somewhere along the way. They were slightly too big, slightly too small, didn't have enough height, didn't have the right mounting holes, all that sort of jazz. So that can you can spend weeks and weeks just searching for the right housing up front for your project. It's crazy, but if you want a nice looking product in the end, rather than, if you do design your circuit board first with all your circuitry, everything's nice and it all works and you're happy with it, you might have to redesign the whole thing to fit in a particular housing. So making the housing choice up front is very important for a product like this, but it's not the same for all products. But in this particular case, I think the housing choice was, 90% of the work. It's not absolutely set in stone. I might find that there might be a showstopper, something like that at the end, but I don't think so. I think I've taken enough things into account that I'll make the damn thing fit into this case. So hopefully Murphy won't intervene and come along with a real showstopper, but I expect this to be my case. And it's quite small, compact, thin, sleek. I like it. I actually like the the curved nature of these things and these little side bits on here for a bit of grip like that. These are really quite nice case. So that's the housing, and I deliberately did it up front because I think it's very important to get that right. First of all, anyone can do a USB power supply, actually design the circuit, lay out a square board and put some rubber feet on the bottom, and bingo, you have a USB power supply. But to have something that's reasonably funky looking into a nice rugged case or something like that, which is in a nice form factor and cheap as well, because one of the main requirements of this supply is I want it to be as absolutely bare bones cheap as possible without going to China. Of course, I still want to get it made in Australia. I want to get my my board from New Zealand again, and a lot of the cost will go there. So I want to choose the cheapest possible component and housing solution that I can get away with, that still has that nice rugged look and feel. And this should be pretty darn rugged. It's tiny. These only protrude out here. There'll be nothing protruding out the other end, just be the USB connector. It'll have a tough Perspex cover on the top, and you should be able to toss this thing around, no problems at all, and it should last a lifetime. So that's the housing. If you like this video, please give it a thumbs up. If you like the series, please give it a thumbs up, and comment on the EEVblog forum. That's where all the discussion is for this thing, and I'll follow up with further parts as I design this thing. Should be interesting. Catch you next time.